Okay, we'll continue with the question now. Any doubts in the 42nd question? Is it clear? Yes, Mark. It's okay. 43rd question. The number of revolutions performed per unit time in uniform circular motion is called. Number of revolutions performed per unit time. The answer is frequency of revolutions. The time taken to complete one revolution is called time period. The number of revolutions in 1 second is called frequency. Okay, let's go to the next question, 44. This is the definition of frequency of revolution. Okay, what is the SI unit of frequency?
Hertz, sir.
Hertz.
Okay, I can also call it as per second. Hertz is a unit, no doubt about it. It can also be called as per second. So both the answers are correct. Because time period is equal to 1 by f, or f is equal to 1 by t. So it's per second. Per second means second inverse.
Okay, sir.
Okay, ma? Yes. So third option is correct. What is period of revolution given by? Come on, guys. Alvin, get on video, guys. I guess Rahil has not logged in back. Yes, Alvin, good. Come on, tell me.
2 pi by omega, sir.
2 pi by omega is correct, ma. Omega is equal to 2 pi by t. What is omega? Angular velocity. Angular velocity is nothing but angular displacement by time. So for completing one complete cycle or one complete circle, the angle covered is, angular displacement is, how much is the angle covered to complete one full cycle, one full circle?
2 pi.
2 pi is correct. Yes, Alvin. 2 pi is the angle. And what is the time taken for completing one revolution called?
Period.
Period. Time.
Period.
So yes.
Time period.
Correct. So your omega will be equal to 2 pi by capital T. Therefore, if you rearrange the equation, you will get T is equal to 2 pi by omega. Second option is absolutely a valid answer. Okay, but that's not the answer for this question. Okay. Look at A also. What is the relationship between V and omega, guys?
R omega.
R
V
omega.
V is
R
equal to R omega.
Yes, Rahil. Yes, ma'am. So V is equal to R omega. Use that. So instead of omega, what I can substitute there in place of omega?
V by R.
Yes.
V
So if
by
I
R.
substitute, which
So
option
here
will I
R
get?
by V.
Yes, we'll get R by
Option
V.
A. So
Option A is also correct. B is
R
also correct. So What is the right answer?
Option D.
Option D is correct. Yes. Royal, it will be great if you could also come on the video. So the right answer is the fourth option. Okay, great. Okay, let's move to the next question. Great, Ryan. Okay. As much as possible, I recommend everybody to be logging in through the laptop so that you will have no problem in keeping your videos on. Okay. 46th question. The radial centripetal acceleration for circular motion is directed. Okay, in circular motion, the radial centripetal acceleration for circular motion is directed. What is the direction of centripetal acceleration? Come on.
D omega by dt.
That's correct. But the question is about the direction. Come on, guys.
So is it A?
Who is answering that? Emmanuel?
Yes, sir.
Yeah, Emmanuel. So it's along the radius towards the center. So there's no doubt about it, right? Because centripetal, what is centripetal? Hello? Centripetal force creates a centripetal acceleration, right? Centripetal force means what? Directed towards the center, correct or not? Yes, you are right. So the right answer is along the radius towards the center. So if you see, wherever the particle is, the force, if you see, will be directed towards the center along the radius. If P is the point where the object is, then the force will be along the direction PO. Okay. Okay, another way of asking the same thing.
So if I'm not able to answer, it's because my Zoom doesn't seem to be working properly. It keeps showing that it's unresponsive.
Oh, is it? Okay, man. No problem.
Yes, sir. Also, my camera, whenever I plugged in the external camera, it increased. Like the same message kept coming.
So you have a Wi-Fi at home, Emmanuel, or you're logging in from
Yes, sir.
mobile data?
From the computer. From the computer Wi-Fi. Using Wi-Fi.
Should not be a problem. You just fix it, Emmanuel, at the earliest.
Yes, sir.
Yeah.
I'm not
great.
sure what the problem is. I think it's with the Zoom, with the application itself.
Then you should uninstall and reinstall it. Huh?
Yes, I tried that yesterday. I don't
Okay.
know
Then-
what exactly is wrong.
Yeah. Get it resolved ASAP.
Yes, sir.
Okay. Now let's get to the question, guys. 47th one. Come on, tell me. In uniform circular motion, the force acting along the radius towards the center is called. Force acting along the radius towards the center. Yes, Kelsey?
Centripetal.
Yeah, centripetal force, correct? Centrifugal is away from the center. Centripetal is towards the center. And what is the formula for centripetal force? We have seen it a few times. I think
mv squared by r.
mv squared by r, that's all, right? Exactly. Yeah. Okay, we'll move on. Okay, when a satellite is revolving around the Earth, what is responsible for providing the necessary centripetal force? Rather than who most appropriate would be, what provides the necessary centripetal force?
Gravitational force of Earth.
Who is that answering?
Sir.
I mean, who this is?
Sir Rahil.
Rahil. Okay, Rahil. Yes. Yeah, gravitational force of Earth is correct. Because you need a force which is acting towards the center, right? So gravitational force is obviously a force which is directed towards the center, and that provides the necessary centripetal force for a satellite to go around Earth. For any body to undergo circular motion, the necessary force is
Gravitation.
not necessary. Centripetal force is necessary. My question
Yes.
was, my question was, for any body to undergo circular motion, what is necessary?
Centripetal force.
Centripetal force. Yeah. In case of a satellite revolving around the Earth, it is a gravitational force of attraction, right? That Earth provides on the satellite.
Yes.
Suppose your electron is revolving around the nucleus. What is providing the centripetal force? Assuming the path to be circular.
So can you repeat, sir? Like,
I'll repeat.
voice is breaking for me.
Oh, I'm sorry. I'm sorry, guys. Electron is revolving around the nucleus of an atom, right?
Yes, sir.
So let's assume that the electron undergoes circular motion.
Yes, sir.
Yes. Now, for it to undergo circular motion, there must be a centripetal force. Yes or no?
Yes, sir.
What provides the centripetal force in that case?
Nucleus, sir.
Or what nature, what kind of force? Yes. For example, here it is gravitational force of Earth. So like that, there, what is the nature of force? What is the force?
Electrostatic force.
Absolutely, Mehta. So that's the perfect answer, right? Electrostatic force between the nucleus and the electron. Nucleus is positively charged.
Electrons.
Electron is negatively charged. Excellent. Very good. Okay, here the answer is gravitational force of Earth. Okay, we'll move to the next question now. When the body is in rotational motion, the particles of the body execute linear motion, circular motion, both linear and circular. None of the above.
Both linear and circular.
How do you say that? Come on, guys, tell me. See here, a body is in rotational motion, means it's just undergoing rotation, which means there is no translatory motion, correct? So if a body is undergoing rotational motion, then what about its particles? They are undergoing
Circular motion.
circular motion. So the only answer is circular motion, right? B is correct. Suppose if I had told something like rolling, then what you can say? Then both
Both
linear.
linear and
Linear and
Yes, but here, when a body is undergoing rotational motion only, then it is only, the particles are undergoing only circular motion. Are you clear, Meda, now?
yes, sir.
Yeah. Okay. We'll move on to the next question. So the right answer is circular motion only. Okay. Next question. Okay, the motion of giant wheel is an example of very simple, straightforward answer.
Rotational motion.
Rotational motion, there's no question about that. Anybody has not seen a giant wheel or has not traveled? Has not been on? Okay. 51st question. The reluctance to undergo a change in state of the body in rotational motion is given by. Reluctance means unwillingness.
Moment of inertia.
Absolutely. Right, Jerry. Good to hear your answer. Okay. Yes. So reluctance to undergo a change in state of body in rotational motion is given by moment of inertia. Absolutely right. Jerry, I have one more question for you.
Yes, sir.
The reluctance to undergo a change in the state of the body in linear motion is given by.
Inertia.
You should be saying mass. Inertia is the
Okay, sir.
tendency. That's right. But then, the quantity which is responsible for that is mass.
Okay, sir.
Yeah. Okay. Good. So in this case, the answer is moment of inertia. Let's move on to the next question, guys. Now, what are the factors that the moment of inertia depends on?
All of the above.
All
of
the
the
above.
above.
That's correct, Gerald. Yes. It depends on the mass. It depends on the position of the axis. It also depends on how the mass is getting distributed because it depends on the R square factor. All of the above is correct. Perfect. Okay, for a discrete system means there are countable number of masses in the system. The sigma represents summation. So which of the following is correct?
Option C, sir.
Option C, absolutely. So if you have three masses, M1, M2, M3, and they are at distances R1, R2, R3 from the axis of rotation, then it will be M1 R1 square plus M2 R2 square plus M3 R3 square. Yes, so the right answer is third option. Straightforward. Okay, we'll move on to the next question. I hope you remember me giving the idea of radius of gyration. We did a couple of problems as well on that. A simple problem on radius of gyration. Please try this, guys. I'll be back on video in a moment. Yes,
So
guys.
it's the moment of inertia of which which particle, sir? Like
It
disk
doesn't
or
matter.
ring
It
or
doesn't matter, Rahil, because they have given you the value itself.
so we have to write mr square.
MK square, MK square.
MK square.
Then find K,
Yes.
that's all. MK square is equal to I, that's all. Very good. MK square is equal to I is 50, M is 10. So you can find
Root
K
5.
square as root 5 is correct.
Root 5 meters.
Yeah, absolutely. Is it clear to everyone?
Yes, sir.
Yes.
Yes, sir.
Excellent. Excellent. So let's move on to the next question. Again, same idea, asked differently. That's all. You are this time given radius of gyration and mass. You need to find the moment of inertia. What do you do?
So 250 kg meter square.
M into K square. That's correct. 10 into 5 square. Yeah, 250 kg meter square is right. Clear?
Yes, sir.
Excellent.
Yes, sir.
Okay, let's look at the next question. Kinetic energy of a rolling body. Direct question.
Option A.
Option
Half
E, right?
I omega square.
Absolutely, Meera. Yeah, half, like just like how you have half mv square here in rotational motion, it is half I omega square. Of course, this is half I omega square for rotating body. Rolling body, I should have also added what? Anybody? Yeah, you can correct the question to rotating body. Okay, for rotating body, E is equal to half I omega square. But if it's a rolling body, what should be the expression for kinetic energy? What is rolling?
So it should be kinetic energy of rotational body plus linear kinetic energy of linear.
Yes, linear motion. So what should it be? No, you're muted, Rahul.
So half I omega square plus half mv square.
Yes. Anyways, for a rotating body, it's half I omega square. Okay. When it's rolling, then you should also add half mv square. Okay, we'll move on to the next question. Okay. I is given, frequency is given. Now kinetic energy of the rotating body is asked. How will you find it out? What is omega, guys? What is omega?
Angular
Angular
velocity.
velocity.
Angular velocity or angular frequency is correct. Okay. And what is the expression for kinetic energy of the body, of the rotating body?
Half I omega
Half
square.
I omega square.
Yes. Good, everyone. Who is answering? Good. Half I omega square. And what is the relationship between omega and frequency, guys? Omega is angular frequency. Tell me the relationship between omega and time period. You have seen
So
that.
it will be d theta by dt.
T is equals to 2 pi by omega. Or
Yeah.
omega is equals to 2 pi by t.
Right, Meda. Yes. Rahil, actually, that's where we start. D theta by dt. But d theta is 2 pi and dt is capital T. So omega is equal to 2 pi by capital T. We had seen, right, in one of the previous questions.
Yes.
Yeah. So your kinetic energy is going to be half I omega square, but then omega is nothing but 2 pi divided by T. Correct? But what is 1 by T? Isn't it frequency? I hope you remember the relationship between frequency and time period. Capital T is equal to 1 by F. If you don't remember it, please write it down. Capital T is equal to 1 by F. So kinetic energy can be written as half I omega square, but omega is 2 pi by T, but 1 by T can be written as F. Therefore, kinetic energy is equal to half I into 2 pi F the whole square. Instead of omega, you can write it as 2 pi F. So the relationship between angular frequency and frequency is omega is equal to 2 pi F. Omega is equal to 2 pi F. And within brackets, you can write F is equal to 1 by T. F is equal to 1 by T. Frequency is equal to 1 divided by time period. So now you can very easily tell me kinetic energy is half I
1000 pi square J.
1000 pi square J, right? So let's look into that. 1 by 2 into I, which is 5, into omega, that would be 2 pi into 10, 20 pi whole square. So 400 pi square, 400 pi square into 5 into 1 by 2. So you get 1000 pi square. That's correct. Omega is nothing but 2 pi F. Please note down, everybody. Can we move on to the next question, guys? Have you noted down?
Yes, sir.
Yes.
Kelsey, done, Kelsey?
Yes, sir.
Excellent, excellent. Okay, let's move on. Straightforward question. The physical quantity that is analogous means similar to force in translational motion is dash in rotational motion.
Torque.
Torque, absolutely. So similar to force, in rotational motion we use torque. Okay, let's look into the next question. This is also straightforward. What is torque equal to? Everybody look at the question. What is torque equal to?
I omega.
IA. I alpha, sorry.
Yes, ma. Yes. How is it, Meda? How did I ask you to remember or connect?
F is equals to MA, sir. So torque will be equal to IA, I alpha.
Exactly. Exactly. Very good, Meda. Yes, because F is equal to ma, right? It's well known to you. Equivalent of F is torque in rotational motion. Equivalent of mass is moment of inertia I. Equivalent for acceleration is in rotational motion alpha, angular acceleration. Therefore, torque is equal to I alpha. Clear?
Sir,
Yes,
excuse me,
Rahul.
sir. Sir, in the last question, there was an option like couple, sir. What does couple mean?
I'll share it. Jeril, I think explain to Rahil what is couple.
Couple. Sir, Titanic ship, sir.
Yeah, very good. That's what we were expecting. No, mute yourself. Okay, fine. Okay, yes. Anybody else? I am sure Kelsey knows. Kelsey, tell me what is a couple?
So equal and opposite forces acting on a body.
Absolutely, absolutely. So, Rahil, you got it, Rahil?
Yes, sir.
Equal and opposite forces which are acting on a body. For example, of course, you being in 12th, you would have learned it in electrostatics where you have a dipole, electric dipole, placed in external uniform
Yes, sir.
electric
Yes,
field.
sir.
Yeah, there is a couple which acts, which means you have two forces both in opposite direction, acting and they're equal in magnitude but acting in opposite direction. That constitutes a couple.
Opposite direction.
Yes.
Yes, sir.
So that can produce a torque. That of course that can produce a torque, but that's not the only way to produce a torque. Correct.
Yes.
Therefore, it's not a couple is not required for a body to rotate. All right.
Yes.
Yes. So couple is not the right answer. But good. Rahil, you asked the doubt. Is it clear to you? What is a couple?
Yes, sir.
Awesome.
Sir, can you repeat?
Yeah. Is it Emmanuel?
Yes, sir.
Yes, Emmanuel.
No, sir, it's Gerald, sir.
Okay. So what's a couple? Couple is nothing but two forces which are acting on a body, equal in magnitude but opposite in direction. For example, let's say this is a body. One force in upward direction, another force in downward direction. So what happens? It tends to rotate the body.
So like a cyclone, sir.
Like Gerald.
Understood.
Okay, guys. So even if you have to open a tab, right? You'll use two fingers minimum, right? Are you able to understand?
Yes, sir.
Yes, sir. So that's two equal and opposite forces acting in of course, two equal forces acting in opposite direction, producing a rotation. All right, that's called as a couple. Is it clear?
Yes, sir.
Yeah. Okay, great. We'll just move on. I think this is something which we have seen. When a body starts from rest and rolls down, which of the following is conserved? This is also
The
straightforward.
total.
It's the total energy, total mechanical energy, right? So because when rolling is happening, which means rotation and translational motion is happening, definitely when the body is rolling down, potential energy is
Decreasing.
decreasing and kinetic energy is increasing, right? So at any point, if you see, what is conserved is the total mechanical energy, which is the sum of potential plus kinetic energy. That will be conserved. So the right answer is total energy. Let's move on to the next question. Okay, we have learned parallel axis theorem, right? So moment of inertia of a rigid body about an axis passing through its center of mass is I naught, and moment of inertia of the same body about another axis parallel to the first axis is I. Then what can you say about I and I naught? I naught is through the center of mass. I is the parallel axis. What can you say about the value of I in comparison to I naught?
I is lesser than I know.
How I and I naught are related? Can anybody tell me the equation?
Sir, I is sir. I naught is equal to I plus mr square.
I naught is your ICOM. Isn't it I is equal to I naught plus MR square?
I is equal to I naught plus. I thought it was the reverse. So I is equal to I naught plus
MX
mr
square
square.
or MR square. So I is I is mr square added to I naught. So I is naturally, obviously.
Greater than I naught.
Yes. So the right answer is third option. Is it clear to everyone?
Yes, sir.
Yes. Okay, what is a mathematical statement for parallel axis where IC represents moment of inertia through the center of mass?
Option A, sir.
Option
Option
A.
A.
Yes.
Option A.
Yes. So IO is moment of inertia through an axis which is parallel to the axis through center of mass. So the right answer is first option. Okay. Fine, guys. With that, I think we will conclude today's session. Any doubts in what we have discussed, guys? Is it all clear to everyone?
Yes, sir.
Excellent. So I appreciate all of you who have
Yes, sir.
come for the class, right? Kagan, Abigail, Alvin, Emmanuel, Cheryl, Kelsey, Meda, Rahil, Shamita, Saumita. Yes, I think I've taken a list of everybody. And special appreciation to all of you who are participating, right? And next level of appreciation for everybody, all of you who have been on videos, guys. Kelsey, Alvin, Rahil, and partly Meda has been on video, Emmanuel also. Please fix your videos as app, okay, so that the participation can still be better and very, very lively, okay. So all the best, guys. Have a wonderful weekend. Take care. Announcement is tomorrow there is no class, okay. We'll have our next class on Tuesday evening, our regular class in the college, okay. I appreciate
Yes.
everyone for attending the
Thank you,
online session. I hope you benefit from the recordings as well, those who had gone for NSS.